We discussed in the last video what stationary points actually mean, and what they mean is that the gradient dy by dx is 0. So we're now going to have a look at a problem where we use that to find the coordinates of some stationary points, as in some maximum and minimum points. So first things first, we know that stationary points are about points where the gradient is 0, so we need to find the gradient. Just one quick aside, it might ask us to find the minimum or maximum points of this graph here, y equals x squared plus 54 over x, but it also might say find the minimum or maximum value of this function. It's essentially the same problem but asked in a different way, so just be aware again that there's different ways of asking the same thing. So we want to find maximum and minimum points, stationary points, of this y, which is equal to x squared plus 54 over x. So what we've got to do is we need to find points where the gradient is 0. So let's just write dy by x is 0 at the top. Keep that in mind. Well, first things first then, let's differentiate. dy by dx, you should have prepared it first, but let's assume that you have. This x is a power minus 1, so when we multiply it, we get minus 54 over x squared. You can work that through on your own if you need to. So now we want to put the gradient dy by dx equal to 0. So let dy by dx be 0. Oops, b is equal to 0, not greater than 0. And then we have 2x minus 54 over x squared equals 0. Like that. Now if we solve that, it will give us the x coordinates of the stationary points. So let's try and solve it. Let's rearrange. We get 2x is equal to 54 over x squared, and therefore let's multiply both sides by x squared. We get x cubed, and divide both sides by 2. It's 27. Hopefully this is looking familiar at this point. We then can cube root to get x equals 3. Bear in mind that minus 3 is not a cube root of 27. So the x coordinate is 3. We haven't quite done all our job though, because it wants the coordinates of the maximum or minimum point, and it wants to know whether it is a maximum or a minimum. So at the moment we've just found the x coordinate. Now you've done this before. We know how to find a y coordinate. We use our coordinate function, which is up here, the y thing, and we put in our x value, and it should give us a y value. So let's put x equals 3 in that purple function. That gives us y is equal to 9, that's 3 squared, plus 54 over 3, which you should know from darts is 9 plus 18 is 27. So the coordinates of this turning point, or this stationary point, are 3, 27. Now what we want to do is classify it, as in, we know it's a stationary point, but from before, is it a stationary point, a maximum one, a minimum one, or what we call a point of inflection? That's the question. Well, we could sketch the graph. However, this is not an easy graph to sketch, and I'll leave it as a challenge for you, considering what happens when x is small and positive, and big and positive, small and negative, and large and negative. What you should find, if I've done my sketch right, is it cuts somewhere and it looks a little bit like this. So it does appear that there is from just looking at the graph and knowing that this gradient is negative, dy by dx is less than 0, this one is positive. So in that case, because it goes from negative to 0 to positive, it looks like it should be a minimum point. However, you are not expected to be able to draw the graph of x squared plus 54 over x. So what other options do you have? Well, this is a little bit new, but no new skills, just new application of the skills that you've already got. What we need to do is differentiate again and use what we discussed briefly last time. So if we differentiate again and put our x value in and it's less than 0, then it's a maximum point. If we differentiate again and put our x value in and get something that's bigger than 0, it's a minimum point. So let's try that. We know that our gradient is 2x, I'll get a decent pen, 2x minus 54 over x squared. If we prepare that properly, we'll have 54x to the minus 2. So let's differentiate again. We should end up with that. Now we have to put in x equals to 3, because that's the coordinate. Looking up there at the top, that is the coordinate. They are the coordinates of our turning point. We don't know what type it is, although from our graph we think it's a minimum. So if we put x equals 3, we should find that the second derivative, d2y by dx squared, is equal to 2, and then it's going to be plus 108 over 3 cubed, because 3 to the minus, well, x to the minus 3 means 1 over x cubed. So just take your time to convince yourself of that. If you need to pause it and check that you agree with this, then do so. But the end result is, whatever that equals, we don't really need to work it out. I think it comes to 6, but it's irrelevant. All we need to know is whether it's bigger than 0 or less than 0. Clearly that's bigger than 0, because it's a 2 and a positive fraction. And because of that, if we go back to our slide, this information you need to learn, because it's bigger than 0, down here in the bottom right hand corner, then we can conclude from this that this point at the top, let's go back to the original point, therefore this point is a minimum point. There's lots of work there, but it's not that new, so please practice some on your own.